Good day, dear colleagues. Today, I'd like to discuss the evolution of medical oncology in colorectal cancer. That is prime meat served with AI potato. Just like a great steak needs the right side dish to shine, our clinical expertise, the prime, needs AI as the potato to amplify our precision medicine. I am Teng Hao Wei, come from Taipei Veterans General Hospital. I am a medical oncology, and my expertise is in treating CRC. Here is the content from Gen AI-based Blender.
Let's dive into part 1. The medical oncologist, MD, at the multidisciplinary team, MDT, and why artificial intelligence.
In the MDT for colorectal cancer, the medical oncologist acts as the glue. We mix insights from surgery, pathology, and radiology, etc. But today, the glue has become smarter. With AI, we don't just coordinate. We integrate data science, clinical trials, and web-based tools to bridge the gaps in patient care.
AI, the main component of glue. Today, we now face not only patients, but also artificial intelligence. Before talking about AI, understanding the AI terminology and evolution, from simple symbolic rules to the complex world of generative intelligence. What is AI? The Turing test. Let's start with one name, Alan Turing, 1950. He asked one core question: can machines think? A simple way to test it, the Turing test. The idea, if a machine can talk like a human and you can't tell it's a machine, then it passes. Turing's paper was the beginning of AI, and the Turing test became its goal. The evolution of AI is a continuous spectrum, not discrete categories. It started with symbolic AI in 1950. Like Iron Man's first suit, we did everything ourselves. We needed many experts to help us. Then we had machine AI, like a Mark I. Then came a big jump, deep learning. With GPUs and Python, machines could learn much more, much faster. Now we had a good Iron Man suit, but the steps to put it on were difficult. 3 years ago, we had LLMs, but we still needed our hands to wear it. Finally, 1 year ago, we got generative AI. For example, Claude. It's a great and charming Iron Man suit. We just walk up and tap, and then we can survive cancer. Symbolic AI. We tell the computer. This is the earliest stage of AI, from the 1950s to the 1980s. Here, humans explicitly program rules, logic, and variable relationships. The system executes those rules. It does not learn or adapt. Input, data plus rules. Output, answers. Limitation, cannot generalize beyond pre-programmed rules. No learning from new data. Next is machine learning, where the computer learns the rules from data. In basic ML, humans engineer features and choose algorithms. Rules emerge from data patterns, not hand-coded. Input, data and answers. Output, model, rules. Paradigms, supervised, unsupervised, reinforcement. Examples: SVM, random forest, cancer prognosis models. In deep learning, humans design architecture and loss function. Multi-layer neural nets auto-extract features. Raw data to learned hierarchical features. No manual feature engineering. GPU and big data. Examples: CNN, pathology image AI. Now we have the LLMs and generative AI. The computer creates. How does it work? Honestly, there's a lot going on inside. Transformers, self-attention, training on trillions of words, human feedback shaping the model. It's complex. But here's the good news. We don't need to understand all of that, and we don't have to. This is like Iron Man's newest suit. You don't build it. We just tap once, and it works. For example, Claude. Our job is just this. We prompt, and we check the result. We guide it, and we feed back. We tap once, and we get to work.
Here is the comparison: symbolic AI versus ML versus LLM/Gen AI. In symbolic AI, humans wrote every rule. We coded everything by hand. The system was fixed. It couldn't learn and it couldn't generalize. In machine learning, the shift began. We no longer wrote the rules. We designed the model and the features, and the data trained it. It could learn patterns and work well within its domain. Now, with LLMs and generative AI, our job is no longer to code every rule. Now, our job is to master the fundamentals so we can command the AI.
The real paradigm shift: human plus AI. So here's the real shift. It's not human or AI. It's human plus AI working together. I call it prime meat served with AI potato. We bring the meat, AI adds the rest. Our goal is simple: to create real applications, not theory, things we can actually use. And in this new world, what is the human role? First, we find the unmet need. AI can't tell us what truly matters. We do. Second, we still bring the rules and the logic. We give the direction. And third, and most important, we are the gatekeeper. Before we let AI run, we must learn enough to judge its work, to know when it's right and when it's wrong. And always keep chatting with it. Keep asking. Keep testing. On the right, you see what AI can do across the spectrum. Symbolic AI gives us gene annotation. Machine learning gives us survival models. And generative AI does much more, building web tools, reviewing papers, working in R, Python, Blender, even slides. But here's the warning. Try it yourself and you'll see it can hallucinate. Look at this painting. Ask AI for Van Gogh, and it may give you something that looks right, but isn't real. That's exactly why we stayed a gatekeeper. AI is powerful, but the human stays in charge.
Now we move to part 03 for the practical demos using both machine learning and generative AI, focusing on Still-Varga drug selection and NGS.
For patients with late-line refractory metastatic colorectal cancer, choosing the right drug, such as Lonsurf or Still-Varga, is challenging. Traditional programming alone is not enough. In this demo, I'll show how machine learning can build a dynamic nomogram to predict patient survival, helping guide this critical drug choice.
Generative AI. Create annotation for NGS. Let's talk about NGS, next generation sequencing. Today, NGS is the backbone of modern oncology. But there's a problem. A single report is rarely simple or complete. And when we have multiple reports, they become very hard to read. Too many parameters, too many numbers, page after page. So here's the unmet need. We need a systematic way to annotate all of this. Not by hand, one by one, but a real system. And this is where generative AI comes in. We can use it to create that system, to read the NGS data, organize it, and annotate it automatically.
Here is the comparison between company report and self-annotation. Company reports are solid, but often limited in annotation and not real-time. Self-annotation is personalized, real-time, and comprehensive, but the output might be less solid and needs careful human validation. This video will show our system.
Let's summarize the key takeaways. Meet unmet is the idea. Key 1. Generation AI is fundamentally changing the rules of medicine. Key 2. Data is data. The doctor's role is not diminished, but changed to interpretation. Key 3. We must apply the first rule principle when using generation AI. Key 4. Comprehensive NGS annotation is essential for modern practice.